Welcome, everybody. I'm here today to talk about how the Coalition, the Gears of War franchise, the home of the Gears of War franchise, went about migrating a lot of our Unreal infrastructure and workflows to Azure. So before we get started, hands up, who's actually dabbled with Unreal in the cloud at all? Okay, a lot of folks, awesome. So most, which is good. So hopefully something's familiar. Maybe you might learn some things as well. So before we get going, I'll just do a quick intro of myself. So my name is Phil. I am the Engine Technical Director at the Coalition, but I also run a group at Xbox called the Xbox Games Technology Group, where we actually look to share a lot of learnings, tools, technology, and workflows with other groups, mainly in Xbox at the moment, but maybe that will change in the future. If you want to know more about the Coalition Studio and what we do, little QR code if you want, takes us to our website. A little bit about me. I've had a long history in games. I used to work at a company called Rare in the UK quite a long time ago. A lot of history at Xbox, about 18 years. I've dabbled in different things as well, actually. So I actually worked on some video streaming apps at Xbox for a while. I actually left Xbox for a little bit and worked at Slack on their iOS, Android, and desktop clients. And I spent a bit of time at CloudWatch as well, which is a data analytics platform out of AWS. But I've got a lot of experience with Unreal, all the way back to UE2, actually. And I spent about a decade with UE4, UE5. So here's my agenda for today. I'm going to set the stage on kind of why we went about doing this, kind of talking about how it used to work, some of the problems that we faced during that time, then a little bit of a kind of digging into the migration process we went through. Hopefully some learnings from folks of what we did along the way and how we got to where we are today. Then I'm going to discuss our current topology in the cloud, mainly focusing around a lot of the Unreal-based infrastructure and workflows that folks need to just do their jobs day to day. And then I'm going to kind of dig into what did we actually achieve by doing this whole process? Is it something that's was it worthwhile? What do we get out of it? Is it something we're going to continue to do? Talk a little bit about some future projects that we want to take on next, especially with the cloud in mind. And then some learnings and recommendations at the end, hopefully you can take away that might be interesting to you if you're going to do something similar, especially with Unreal. And then depending on timing, Q&A, but happily catch me afterwards, maybe tonight. Happy to answer questions if you have any. So the background, just again, digging into kind of why did we start down on this journey? So for background, the Coalition is made of about 350 folks up in Vancouver, Canada, but we work with a lot of external partners. It's roughly 20 at the moment, so there's a lot of different folks there. And it's something that we've always done, even from the original shipping of Gears Ultimate. We've always worked with external partners, and it's something that our team generally keeps in mind. If we build a piece of tool, piece of tech, a workflow, we try to think, how's it going to work when it's at a different partner site? What do they need to make this thing function? But especially pre-pandemic, we were always it kind of just worked best on our local network with local things that we had available to us, and we always tried to just make it work with external partners, and it was okay. But how did we do that? So to give you a visual of how we work, it is pretty much a 24/7 dev house. We have folks all over the world. They do different roles for us, from different art roles, different kind of strategic partners who do a lot of full co-dev with us, and they are literally all over the world. One thing to call out is this is actually just where their headquarters are. A lot of folks who work with us are actually just at home, and they just kind of work independently. And at the Coalition as well, we actually work very hybrid. So you can work in the office, you can work at home, and we have kind of a mix there. So this is, I've got a diagram a bit later where it's kind of more spread out, but this is kind of the main thing that we're dealing with here. So just to kind of set the stage. And so the way we used to work is that we actually deployed things called P4 brokers with Perforce into Azure. And then we went through and actually connected all of these Perforce brokers around the world that we generated, and there's generally 3 of them, back to our main server in Vancouver using what we call express routes. But with this system, it basically meant that a lot of our folks that actually worked with us had to set up what's called a Perforce proxy on their local site, which then would connect back to our main server. And this is basically the main way that they got all of the information they needed, like code and content, every day. And the reason kind of I spent a lot of time just giving you that diagram and that infrastructure is that 95% of what they got from us was through Perforce. So it's not just code, it wasn't just content, it was all the tools we distributed that way, logs. We kind of used Perforce as a general transport mechanism, which didn't work very well back then, but it's just what we had. And then the big picture we have in the middle here is actually how we worked on site at the Coalition. So if you're on-prem in the local network, you got access to great things like a file share DDC. We had a compute farm for you. We had everything locally, but our partners really had nothing like that. So what we used to have to do was we had to set up, we had the Perforce set up, but then we had to do these kind of very strange setup at partner sites, really just to actually enable them to work. So we relied very heavily on things like a Signiant file share. We would actually copy a lot of things from our file share to their file share. We'd have to get them to set up things like a local derived data cache in Unreal, which is so that they can actually cache all this information. They'd have to buy things like Incredible licenses. They'd have to set up a lot of local compute, a lot of things basically just to get them up and running. And if they didn't have these things, it was a pretty bad time. We had some things where if a user would basically buy themselves and had none of this caching infrastructure, a base shader change, for example, but could take them out for like 24 hours because they had to sit there compiling locally, which was very, very painful. So, and the big challenge for us was that a lot of our partners had to basically manage and fund this entire infrastructure themselves and basically take a lot of cues from us, and it was a lot of kind of back and forth just to get them set up, which is very, very painful. So, so a lot of challenges came with this. Our first caveat with it, we did ship a lot of games this way. We shipped 3 games this way, and it kind of worked. It was just, it was a challenge. So geolocation was one of the big challenges we generally faced, where, because the folks are all over the world and we're asking them to set up their own infrastructure, time zones were different. It was very, very hard to kind of, for our team, to stay on top of kind of like, hey, how's a partner doing? They're further away, they're in a different time zone. Like, problems had to be kind of, triaged over email that would take many, many days. It was just a big challenge for us, and we generally didn't have insights into like how their local network was set up and what they were doing. Bandwidth was a huge issue, especially in UE4 and kind of our old infrastructure. Our team would submit like terabytes of data a day. They would do things like light bakes, submit them in, and basically people would have to sync that like continually through their Perforce proxies that we talked about. And Unreal has this unfortunate way that if you don't have like code and data that matches, it basically just breaks all workflows. So if a partner had a very slow connection or they couldn't cache things fast enough, they essentially had to wait through the weekend and kind of sync everything just to get back up and running, which was super, super painful. We had a lot of problems with local hardware. So the idea of like, hey, could you just go set up an Incredible farm, please, so that you can compile shaders, compile code, was just a huge, huge challenge for a lot of folks. And this is where we did things like our little Signiant share, where we tried to do things like, hey, if we're making a base shader change, could we like wrap up the derived data cache and send it to you so you don't have to do that compute locally? But that wasn't always successful. And as I said, like, some of these stalls could basically take our partners out for like, hours, if not days, when we would do kind of big code changes. And we'd have to do timing, things of say like, hey, only do a shader change on a Friday afternoon to let everyone catch up over the weekend, for example. So. With this structure as well, support and observability was super challenging. Like if someone had a crash or if we wanted to get a log from somebody or see telemetry on like, hey, you're having a bad time loading our editor, it was really hard to get information out of them. Like we would try to do things like copy files to and from Signiant, make our little, the Unreal editor like copy files into their local share, copy them over and back again. But it was just it was pretty challenging to know, and especially if someone was having like a machine problem, we couldn't really diagnose it easily without either jumping on a call late at night, early morning, that kind of thing. So a big thing for us too was authentication. Like the thing that we showed you there was that obviously most of the information you get back and forth was through Perforce, and we used many different layers of authentication in that way, but we could never give our partners access through VPN to our on-prem resources. That was something that, as a company like Microsoft, who we work for, it was a big taboo and it was a no-no. So we actually really struggled to understand like how we could actually give people access to things they need, like maybe Jira or say Unreal Cache or something like that. So, and all of this just actually resulted in really poor onboarding times. So when a partner came in, they did maybe a trial of like, oh cool, we make amazing animations for you. How fast can we get them in the project? It was 2 to 4 weeks before we could be like, okay, you've got the infrastructure set up, you've sunk everything, it's awesome. But then we had to like diagnose like compute problems and like, hey, have you set up properly? And like we'd have to have a lot of back and forth just to figure out could they actually function and work on the project successfully. So with that, we knew how to do something about this. It was kind of like I say, it worked, it was functional, we shipped a bunch of games that way. But especially post-pandemic, we're like, hey, our own team is now facing this problem. A lot of them are at home, a lot of them work remotely. What can we do about this? So with a lot of the knowledge that I gained working at SaaS providers like AWS and Slack, they actually worked very differently, where they didn't actually rely on a lot of local infrastructure, and they put a lot of things into the cloud. So we undertook this process of basically transforming or kind of doing this infrastructure transformation to move a lot of our infrastructure from on-prem to the cloud. And this is how we went about it. So before we started, we wanted to kind of like, really dig into some key tenets of like, okay, what do we want to do and what kind of experience do we want our users to have? The first one that especially us and our IT team was like, we have to unify this access mechanism. Like, it's stupid. We had like 6 or 7 ways of giving access to people. It was a pain in the bum. People really didn't like it. We need to find a way so that we can give everybody, access to what they need very, very quickly with minimal effort and overhead and management and maintenance. So the second one was like, talked about it a little bit earlier. We had kind of what we would say would be world-class workflows if you're on-prem at the coalition, but we wanted to make sure that everybody got that. We want to make sure that everyone had the most robust and efficient workflows as possible so they can do what they do best, make great games. We wanted that flexibility, which was a big one. So like even at the coalition, we are hybrid. So we were like, we need to support people both in the office, at home, fully remote. We need to take all these things into account, and everything should be kind of that first-class citizen at that point. And the last one, which really did bite us quite a lot, is that we need a lot more ways of kind of measuring workflow efficiency and just really helping users when things went wrong. So how could we get more telemetry out of the systems? How can we understand like what that optimal experience looks like? And how can we make sure that everyone is getting that? So with this, we went through this big planning phase. This is a little bit more like Azure specific because that's what we did. But the good thing about Azure is actually they've got this thing called the Microsoft Cloud Adoption Framework, which is actually a really cool thing they've put together for a lot of folks moving things from on-prem to the cloud. So we had some discussions at it. We looked at it. And it actually covers a lot of really key topics that you've got to be thinking about when you're moving stuff from on-prem to the cloud. So a big one is security and identity. A lot of things that you have on-prem are kind of in a walled garden, which is great. But then when you put it up into the cloud, you're like, OK, who can access this thing? How are they going to access it? What does identity look like at that point? Again, our relationship with our IT team when it comes to things like governance management, usually if things are on-prem, the IT team would provision a machine, give it to us, and would kind of work that way. But we have to really think about what roles do people play when it comes to working in the cloud and who takes responsibility of what. It digs into things like regions, you've got different people in different locations. Do you need multiple regions? Do you need fallbacks? Do you need things like availability zones? It kind of digs into this, which is great. A big one that we didn't realize until we dug into this a little bit more was things like networking. If you've got something in the cloud, how does it talk to something on-prem? If you've got build machines on your local network, how does that work? And it digs into that quite heavily, and you've got to kind of figure that stuff out too. And all of this is wrapped in this kind of secure access. We've got to basically make sure that only the people we want come in to our infrastructure and use our infrastructure, because a lot of what people get access to is things like the latest Gears E-Day code, for example. And the big thing about this too is actually we talked to some partners and they were like, oh, I know a vendor, they can go and just help you with this. And our team was like, well, actually, if this is our future, we should probably do this ourselves. We should literally go through this entire process. And it was really great for my team because they really did want to be hands-on here. They wanted to be like, okay, if this is going to happen and we're going to maintain it in the future, I really want to get stuck in and actually do this process myself. And a lot of them had no clue how to do anything in the cloud before we started this process. So with that, we went through this big planning phase where we created some technical papers, and we did it as a very phased approach. I think one thing that was super key when we kind of went through this is something we called an Azure landing zone of if I'm going to put something in the cloud, what have I got to think about? Where am I going to put credentials and secrets? There's things called key vaults. OK, we've got to use those. How am I going to do dev and prod environments like I do locally? It's 2 different machines. Got to look at things like subscriptions. And we kind of went through this process and actually then keyed out all these different things in this space. Identity was a huge one. We know we had to do this unified model, and I'll talk a little bit about this in a minute. But we know we needed something to be flexible, but super safe and super secure, and we could manage this a bit more easily. The big change for us, too, is actually Perforce would have to change. Traditionally, and again, I dig into this a little bit more, is we actually gave access to Perforce through our own authentication layer. Don't tell our security team. And we had to actually move to something a bit more unified. And actually, Helix have something called the Helix Authentication Server, which is really cool. And it provides things like single sign-on, which, again, we had to investigate and figure that out. And then the big thing for us was actually going through all of the Unreal infrastructure and other infrastructure we had and trying to figure out, OK, how are we going to migrate these things? Traditionally, they're just a service you run on a VM somewhere. How do I actually move those things up into the cloud? And things there was the file share DDC at the time. There's things like compute for code and shaders. All these kind of things had to be considered. And then the last one was that we actually had a problem at the coalition too, where we definitely rely on an on-prem build farm. And we, for a long time, wanted to try to scale into the cloud with build infrastructure. We didn't actually know how to do that and how to connect all those things together. So that was a big part of this discussion and planning. So So as part of this, and I'll dig into some of these specifics here, and again, this is probably shouldn't be seen by my security team, but like we had a lot of different ways of kind of managing Auth. And when we went through and did all this investigation, luckily, out of the box in Azure, and I know there's different versions for different cloud providers, there's something called Azure Active Directory or Entra. And the idea is we could actually collapse all of our authentication methods into one, and this was kind of the winner in this regard. And we could actually make all the tools, technology, and infrastructure, including Unreal, which did not support it at the time, actually support Azure Active Directory, which is great. So the idea people could bring their own credentials, we could actually set all this stuff up, and it became kind of the way of us kind of merging the different authentication layers into just that one and that unified access, which was pretty key for us. The other one for us too, and this is probably a little unique to us, but we were tied very closely to the Microsoft corporate network because it's just kind of how we worked. But a lot of what we were trying to do was kind of like a big no-no to the security folks there. So we actually had to migrate a lot of our internal networking and actually the tenant we used already for our Perforce brokers to our own tenant. So we could manage and govern our own setup. And this is actually what they suggested anyway. And it gave us a lot of flexibility to manage things like, we could give a VPN if we wanted to, but that was not the case here. We could actually have things like, better user authentication and token expiries. A lot of good stuff came out of like just setting up our own tenant in the cloud and actually set these things up so that we could work with the infrastructure we were going to pull over. So this is a bit crazy chart, so I apologize, but like it was really, really important to actually make a really detailed like cloud topology diagram, and this came out of that framework. So it makes you dig into things like, okay, what is a subscription? How does that work? What are the things like authentication and governance? Like how do VMs work, and what sort of things who wants access to what? And we have to actually think about all the different roles people would play in the migration, and also post-migration, who would be touching the different environments and setup. So we went through this with all of the kind of infrastructure setup we had and tried to put us in a giant diagram and all just kind of sit around and discuss it together, which was I think needed. It took a bit of time, but definitely worth it in the end. So it actually made it so that when we started our migration over, it was much more clean and simple to actually sort out. So collapsing that all into kind of like a simple diagram, if you will, because there's a lot here, but I'll talk a bit more about it, is that this was our desired topology after kind of going through this big planning phase. We knew what we wanted to do. We knew what we wanted the outcome to be. And the idea is that we wanted to basically create this kind of topology, but then replicate it in the cloud in multiple data centers. And we wanted to basically move, maybe all of our apps and infrastructure to be hosted in public Azure, and for everybody, regardless of who you are, partner, person working at the coalition at home, to access that through public Azure with no VPN, using kind of the secure connection, and then just give you access to what you need. And the idea here was that by replicating it in different data centers, we could bring all of those resources close to external teams, and they didn't have to go through the pain of setting this up locally. And that was the plan here. So with that, we then had to go through and actually dig into the actual application migration process, which was a little bit more confusing and something that, again, it took a little bit more time, and I'm glad we spent the time doing it. So we basically went through all the applications that we ran on-prem today and said, like, who needs access to this? Do the animation team need that if they're in maybe the Far East? Does our co-dev maybe in London need this? And went through and just kind of tried to figure out is it something that can stay here and doesn't have to migrate, or do we actually need it? And then with that, we actually then started going through and every single application had a deep dive session to really understand what does it do? What does it touch? Does it touch something over there? Does it touch something, does it write to a file share? Does it how do people interact with it? And then using these two bits of information, we try to prioritize what was the biggest impact we could do in terms of number of applications and in what order to make sure that, again, we had the most impact with our external teams at that point. And then I think the big thing that we had to do was have deep dive design sessions of well, you may have set it up like this locally on, say, an ISS server with a VM, but what does that look like in the cloud? What's an equivalent? And I think a lot of that, I've seen a lot of people go through these conversations and they say, well, I can just spin up a VM in the cloud and then just lift and shift right and just install it and it's all good, I walk away. But we didn't want to do that. We wanted to be okay, what does it mean to have a code change that supported Azure Active Directory? What did it mean to have things like a virtual network that can be kind of isolated so no one can access it? How do we do proper security? How do we do things like key vaults? How do we set up IAC pipelines, infrastructure as code, so that we can get away from this kind of old pattern of hey, it's just a VM sitting somewhere and I kind of prod it and poke it sometimes. So this is a pretty heavyweight thing that we did here. And then, obviously, as any good plan is you sit down, you kind of plan and execute it. And we actually went and kind of picked the simplest solution first, which was actually the Unreal Game Sync metadata service. I appreciate in the current Unreal infrastructure, that's kind of in Horde now, but at the time it wasn't. And we thought like, hey, everyone uses this. Unreal Game Sync uses it. It's something that doesn't exist today. Epic hasn't actually migrated that thing to the cloud. But let's go through that process together and do that. So we actually sat down, broke that work down, went through the whole process of migrating it, and actually everyone just worked together on that one so they could understand how you go about that process, what you've got to do, and make sure that it will work. And then after that, we actually spun up multiple teams in parallel once we had that base knowledge, and actually then ran in parallel with a lot of the other things that we had there. So like, we work very closely with Epic on the Unreal Cloud DDC, and we've moved a lot of other infrastructure up there, which I'll talk about in a minute. And this is pretty successful. So, and then, it's kind of interesting. I'll just throw up some questions here. These are the kind of questions we have to start asking ourselves as part of this application migration. So, what is the Azure equivalent or the cloud equivalent of the thing I'm running locally? Like if I'm running like MS SQL, what's up in the cloud? How does that work? Is it SQL Server? Is it something else? Like these are the questions you have to ask. Does your application read and write to local storage? How's that going to work? You don't have local storage in the cloud. You maybe have a local VM, but then how do people get access to that? Again, something to consider. How do other applications speak to your application? Again, UJS metadata service is something that gets, the build machines, they write to it and say like, hey, here's a build, here's some kind of tagging information, and then all of the Unreal Game Syncs read from it. Like, how's that work? How do people work with that? Do you need redundancy? And this is something that we did consider quite a lot where, like a VM, they can go down, and when it goes down, does it stop your entire team? So do you want to build, redundancy into your solution and have multiple of these things running, have them in different data centers? How does that work? How are you going to deploy your application? And again, if you've not gone down this journey, and I'll talk about it at the end a little bit more too, but infrastructure as code is your friend. You don't want to be hand deploying this stuff like maybe you've done in the past. And my team was as bad as anybody's of like, hey, VM, just install it. It's cool, all good, right? It's like, well, no, actually, something definitely that should be invested in. And then how are you going to monitor your applications when it's in the cloud? Like, what have you got available to you to actually go and do that kind of work? So again, good things to consider, I think, when you go on this journey. And again, sorry for the eye chart, but this is kind of the thing that we started doing, which kind of like tries to answer all those kinds of questions, but in kind of more of a cloud-first approach. So this is our what we call TC Remote Logging service. It has the ability to take all telemetry and all logs from any application running on a user's machine and basically bring it back home to the coalition so we can use it to diagnose things. And it digs into things like who needs private access, what's got public access, how do you do restricted access, how do I monitor it with things like app insights and dashboards? What sort of storage do I use? Like I need to probably use blob storage instead of like a file share. These are the sort of things that we had to kind of map out per application. And this is something I kind of want to hammer home is like, it's worth doing this up front rather than just kind of bumbling your way through it. We did that when we first started. It was like, oh, it'll be fine. And then we ended up making quite bad design choices, I think, when we did this, which we had to kind of readdress and kind of go back to. And once you've learned those practices and kind of like design infrastructures you should be using, you can apply that to other things too. So it's definitely worth spending the time to actually think about this stuff. So to dig into a little bit now, like, that's kind of the journey we went on. I know it's a very 10,000-foot view. And this didn't happen overnight either. It took us maybe about 18 months to kind of move everything that we wanted to up into Azure. This was mainly because we're in production as well, and we had to do a lot of like, hey, it still needs to work locally while we stand up this kind of second infrastructure and then slowly migrate people over to what we have today. So going back to my original diagram, we basically deploy into, at the moment, I believe it's 4, it might be 5 actually, I always forget, I need to update this diagram, but it's basically 4 data centers. We've got 2 in North America, we've got 1 in Europe and 1 in the Far East. And basically, we chose these locations because they're the closest to our partners today. And this is where we deploy all of this infrastructure. And I'm going to gloss over a lot of this, but we deploy a lot of Unreal topology and infrastructure now up into Azure, which anybody can access. So this includes things like we have the UJS metadata service. We use the Unreal Cloud DDC. We actually use fast build over things like Incredibuild. We've actually made it very, very cloud-first aware. So we have things like caches in the cloud. We use authentication, so it can be encrypted in transit from anybody working at home. We have our own version of a shader compiler that we run up in Azure as well. And we do things like build infrastructure, logging, symbols, crash handling. It's all up there, close to users as they need it. And then if you've got a local network, some of our partners still stand up a little bit of local infrastructure. Things like the shared Zen servers are very good locally if you want those. Actually does speed up workflows. Things like a build cache locally, you can still have a P4 proxy. But the great thing is if you're a single person, you're jumping on the project, you don't need anything. You can literally just connect to Perforce, sync some stuff, and connect to all of our infrastructure on day one and get working, which is, again, night and day difference from before. So. And then taking this a little bit further, it's allowed us to build brand new topologies and kind of, I guess, capabilities that we could never do before. So at the Coalition, we have what we call the pre-submit validation tool, where anybody who submits into Perforce actually has to go through a gauntlet of tests where we compile code, we cook all your changes for every platform before you're allowed to submit. We're a very large team, and one break, I'm sure everyone's heard the analogy, if everyone breaks the build once in the lifetime of the project, the build is broken every day. This is to avoid that. But to an end user, regardless of where they are, they use our little submit tool, and then we actually scale this into Azure really, really well, where we actually run a TeamCity instance in Azure. There's a bunch of VMs. We co-locate it with things like a snapshot server, a Zen server, fast build, Azure Shader Compiler. And then we actually bleed into on-prem if needs be. We've actually got pretty powerful machines on-prem at the Coalition. And if we're doing like really heavy cook sets, for example, we'll actually lean into those because we know the IOPS are a little bit better than what we get in Azure. But to the user, it's all seamless. They don't care. They just it just works. But it gives us that real big flexibility that we never had before with this kind of solution. So, and then telemetry. We have so much telemetry now, which is awesome. And it means this kind of like cloud-first topology, and through things like the TC remote logging tools that we have, we gather all metrics, all crashes, every log from every user and every application around the world, which is awesome. And so this is my diagram I mentioned earlier, the little specks, so basically where people actually are versus where the head office is. I just don't think we've got someone in like Antarctica or something like that, but they're pretty much everywhere. And the good thing about this, it really lets our team be very, very proactive around like what is the user experience, how are they faring when it comes to using Unreal, the editor. If they're having a terrible experience, we have alerts and things that people can see. And it's really, really awesome to kind of just make sure we stay on top of like, just, is this topology working for everybody? Then we pipe it down to on-prem. We use Splunk today, which is a data analytics tool. But we're looking to migrate our entire logging solution to the cloud sometime in the future. But yeah, it's definitely been a game changer for us. So with all this, was it worth it? I guess that's the question, right? So there's a lot of challenges that we had initially, but did we solve them all? So let's look at this. So I think the outcomes here is that definitely, the cloud infrastructure we had problems when we talked about geolocation. We've got partners around the world. It's very hard to like monitor what they're doing, make sure they're set up correctly. They had to do a lot of different work that traditionally, it was just hard for them to do and manage themselves. But now this new solution is that we actually manage a lot of the infrastructure that they need. They can add things like, a shared Zen server if they want, but a lot of it, they just don't have to. So, and by having all of these, this setup and this infrastructure closer to our partners, it really means they can just leverage what we deploy for them, and it kind of takes a lot of the guessing out of it for it. So if we're just spinning up like, a brand new partner who works purely on, say, animations in the editor, they don't have to worry about this kind of stuff, which is awesome. And again, as we spin up new partners and actually work with them, and they're in a different location, this is where things like infrastructure as code come in. You can just say like, hey, here's a new region, there's a lot of new folks here, just go deploy that. And a lot of both Unreal infrastructure and our own does things like automatically replicates across all regions, which is very, very helpful when it comes to spinning up new things. So the one thing that I wish was better, and it's still a problem, but it's a little bit better, is I think the size and scale of UE5 development means that bandwidth and latency is still a problem for anybody. If you have just a low internet connection or, again, high latency ping to a data center, it's still going to be an issue. So there is great tech that I encourage you to invest in if you haven't. So there's something called the Perforce Virtual File System that we've actually open sourced. And if you're looking for virtualization of content and not syncing down everything like art content, I encourage you to check that out. A lot of folks use that already. Unreal has its own virtualized asset system, which is awesome for U assets. Again, highly encourage you to look at that. Unreal Cloud DDC has been a game changer for us of just kind of like making sure everyone has access to that cache data that they need when working with both the editor and cooking. A new thing that we've deployed since 5.5 is what's called DDC replays, where the idea is that you can record all accesses to the DDC and let people sync the DDC through UGS. That's something that's relatively new. Epic don't talk about it too much, but it's been great for partners working remotely, where you basically just absorb all of the downloading of the derived data cache when syncing, which is, again, great for users who do things like schedule syncs overnight. And then the shared Zen server, which, again, relatively new from 5.5. They've been doing some fixes in 5.6. Again, been really, really good for us in that space, too. And then I think there's still more work that could be done here. I do say things like workstations in the cloud. We have experimented with that, where you could actually just have a virtual station that someone kind of remotes into with something like Parsec. A lot of the art teams don't like the latency either, so there's a few things we've got to work through there, but potentially an option in the future, and we're still digging into this of like how we can make this better. So I think we've definitely solved the local hardware problem. Like, we basically have all the infrastructure in the cloud that anybody needs when it comes to things like fast build, Azure shader compiling, and we scale these up and down dynamically, which is awesome. So if people have like heavy workloads, maybe say in the Far East or in Europe, it basically just handles all that for them today, and they don't have to care about it or worry about it, which is, again, the power of the cloud here. Again, you can speed this up locally by having a shared Zen server, and our bigger partners do that. It's very, very helpful, but it's not required. And then, we had experiences, I think I mentioned before, a single shader invalidation would actually take partners out for days as they kind of catch up. We actually don't notice it anymore. The rendering team and probably too much, the rendering team and the tech art team just submit them whenever they want, and it actually doesn't affect any of our partners because they get this kind of shared infrastructure, which has all the caching on top of it, which is great to see. So I think we've solved the support and observability quite well. We have a lot of monitoring, like I talked about, and alerting on all major infrastructure, and for the partners too. If they're having like high crash rates, they're having massive amounts of issues, we get to see that really quickly, and we can kind of work through that. One thing we have done, and I think this has been a bit of a game changer too for our team, is that we've actually deployed frontline support folks in different time zones. And I think that's something we never thought about before, but it's definitely helped having people have coverage during our nighttime. Kind of, we're in Vancouver, we're kind of minus, 9 or wherever, PST, or the PST time zone. So having that has been very, very useful just to kind of keep everyone running, knowing that we are a 24/7 development house. And we get all of our crashes and logs now, which is awesome. Like, again, it's probably too many, but that's, but I'd rather have them than not have them. And I see my team react very, very quickly when we see a crash come in that's blocking somebody. They don't have to ask, like, where's that log? Where's that crash? I don't know where it is. It's just all in the same place, all through the same infrastructure, regardless if you're on our site at the coalition or you're a remote partner, which is, again, been a game changer for that turnaround time and fixing things. I think authentication has definitely been solved, and our IT team just loves this new system where you basically bring your own credentials, your own setup. The access we have is pretty easy and secure, and we have no VPN requirements, which is a big thing for us because we didn't really feel like we could make this infrastructure for VPNs work as other people have maybe for their studios. And I don't think we actually need it, which I think is a bit of a differentiator from what we do to maybe others. And it's been great for users. Onboarding time now is basically a couple of hours, I think, rather than like 2+ weeks. And we have this regularly. Like, we'll have a team say like, hey, we've got an additional person who's going to be on for a couple of weeks or something. No problem. IT just lights them up, off they go. They've got all the infrastructure they need. And it's been much, a huge difference and a game changer for us, I think, of working with external partners, especially on short-term contracts. And the last one I didn't talk about, but something that I love to talk about a little bit, is that we're definitely helping forge the path for other UE studios, especially in Xbox. Like, from what we've done, we try to kind of stand up all this stuff in a generic way. And this is where things like infrastructure as code come in really nicely. It's like, if you set this up, you can just hand it over to somebody else and go like, target your own infrastructure, target your own tenant, and you're going to get the same things we have. And we share a lot of this internally. And this is kind of what I do through things like our Xbox Games Technology Group. This is kind of a completely different Unreal Fest talk, but I'd love to talk about it sometime. And we are trying to slowly, if we can, see how we can share this more widely with industry. We've actually open sourced 2 bits of technology already, and we're going to continue trying to do that where we can. So with that, talking a little bit about future projects, because there's some stuff here that, probably if you've caught any of the other Unreal Fest talks, there's stuff that Epic is doing in this space too, which is definitely really awesome, and it's definitely things we're looking into in the future. So the first one for us is probably adopting more of Epic's DevOps tools where appropriate. Like, they've built a lot of cool stuff. We had this stuff way before things like Horde became public. So, there's an intention going forward, and we actually have a version we've stood up internally of Horde. I'm sure other people have too. To work in Azure as a kind of first-class citizen is kind of where we're getting to, and we're kind of adding capabilities. We're in production, so we're probably not going to move this project, but it's something that we're going to probably look to move from TeamCity, which we use today, to Horde for our build system. We have our pre-submit validation system. They've got Gauntlet, which is kind of the same thing in terms of how it works. So we're kind of evaluating, do we get rid of our own system, but just leverage what they have? And then we get asked a lot about this, but like, yeah, moving from fast build to Unreal Build Accelerator is something definitely on the cards for us in the future. There's a few things that are slightly different in terms of authentication, et cetera, which fast build, our version supports, which theirs doesn't today. But we're working very closely with Epic and giving them feedback and advice of like why we wouldn't move today, which is great to hear. And I think they're trying to solve all those problems and it looks great. So. And the other one I talked about is I'd love to have a cloud-first telemetry solution as well. So I'm not, at the moment, we actually send a lot of data through the cloud, encrypted, et cetera, back to on-prem. It's like log files and things like that. I'd love to have just a self-serve solution that's in the cloud that even our partners could go access. We actually do send them reports and other things on like how their users are doing with things like editor startup times, pi times, and things like that. But a lot of it's actually sent from us internally. So there's a great piece of technology which is, they've got in Horde, which is called the Studio Telemetry plugin. You can actually monitor what your team is doing with a lot of these key KPIs. Looking to put things like Splunk into the cloud. It is supported, we just need to move it. And I think just getting more on top of kind of these real-time telemetry and alerts is pretty key as well for us. So then just, some learnings and takeaways before we kind of wrap up and maybe got some time for Q&A. I think some learnings, the key one for us is that it took a lot longer than we thought it would. I think it was interesting. Everyone was super keen. They were like, hey, this thing looks awesome. Like, the cloud looks great. But like the rigor we put in, I think we completely underestimated how long it would take to actually shift our first application up to the cloud, make it secure, make sure that it would work. And I think there's a lot of like, we didn't know what we didn't know. We asked around a lot of like, hey, has anybody done this before, especially with our scenarios and setups? And it was basically like, not really. So I think, doing the first process and having a bit more rigor around, especially Unreal Game Sync doing it first, taught us a lot. And then it sped up the other ones. But yeah, it definitely took a lot longer than we originally thought going through that. And that does tie into the idea of like, there is no reference examples for anybody usually in this space. Like, Epic have their own versions of things like Horde, et cetera, and they've got nice things like setups for potentially that will work with AWS, for example, but a lot of it's just like the last mile generally has to be done by you. So even asking internally at Microsoft, it's something that, again, I think cloud providers need to build a bit more muscle around this and maybe give better examples of how to do this to maybe speed up teams. So again, I think that kind of definitely added to the process and kind of how long it took for us to do. So I think the good learnings, and again, it's great to like hear Epic talk about this, is that they've actually prepared a lot of their tools and tech, and they're going a lot more in this space to be like kind of, their DevOps tools are ready to be deployed to the cloud. But I will caveat where, again, we're a different cloud provider. We're using Azure instead of AWS, so there's definitely like a little bit of work on that last mile to kind of get it over. Things like authentication is different. The way they've set up is slightly different. They, for example, use a VPN today for their connections. So there's a bunch of stuff we had to consider, but a lot of it is there. So Dan, definitely look at it. There's some good stuff you can definitely use in that regards. So, and I think the big learning that our team took away out of this is that they actually we've changed our mindset about developing tools and technology going forwards. Like a lot of it used to be like, oh, would I put it into the cloud? And now it's like, why would I not put it in the cloud? And I think that's been a big mind shift. I think for a lot of our team, embracing things like Azure DevOps pipelines, where the idea is you can have like, you submit a change, you've got a build system that goes through, you can do some validation, it auto deploys for you. Once we put that in place and people realize how powerful that was, they just have never looked back. They feel like much more comfortable putting in, say, like an intern on the project because they can make changes quickly, roll them back quickly, where in the past that was really, really hard to do because a lot of it was very manually deployed, which was a bit of a challenge. And then when you lace in nice things like code signing and things like that, it does become much, much more simple to just embrace that kind of topology and that kind of workflow going forward. So if you're going to do this again, hopefully your teams would be very similar, that you find that this is just very, very powerful for what you do. So. And then some recommendations. I think just kind of like looking back at this over the past little while when I was coming up with this, I thought I'd just kind of share some of these, some good takeaways if you're kind of coming on the same journey that we've just gone on. So I think the first one is like lean into as much as you can Epic's cloud DevOps tools. Go ask them, go look at what's there. They're happy to answer questions on it. But they've done some amazing stuff, especially now, like all the stuff they've done with the Unreal Cloud DDC, with Horde, with UBA. You're probably hearing, like, I think a lot of their future is kind of cloud-based. So I think getting on this is kind of definitely very, very interesting for a lot of people. And I think, again, they're going to be investing more and more in this space, as you've probably been hearing. So again, it's definitely worth looking what they've got. They have done a lot of great work in this space. I know it sounds a little cliche, but you really should just make a plan. I think it's something that like really sit down with your team and go like, what are we trying to do? What are we trying to migrate? What do you want to move in priority order? Really make sure you understand like your architecture, your dependencies, maybe to on-prem things. Like really have a think about that. So that you kind of like get ahead of that before you actually start on that process. I think is very, very key. So. And that this is combined with like really make time and space for your team to do this. Looking back, I think with my team, we really didn't carve out enough time. We basically sat down and was like, oh yeah, this is something we can do on the side. It's fine. We had like juggling priorities with production, just like helping the team out. And it was something that I wish we just kind of like sat down, did together. It would have gone a lot faster. I think we would have got a lot more out of it much more quickly. But again, hindsight's 20/20, right? So. I think a big one, and we did this, and I think this is kind of why our first migration failed a little bit, and we had to kind of go back, and it took us so long, is like really don't lift and shift. Like don't just go like, hey, here's a VM provision in the cloud, go deploy. You're just going to hit problems, I think, in the future. So really just, think about what you want to do, looking at things like infrastructure as code, like embracing, Bicep, Terraform, whatever those things might be. Look at security models. Really look at like how your application is going to work and live in the cloud. I think is pretty key here. And again, I think it gives you a lot of like safety as well with a lot of these like DevOps pipelines that they have in the cloud now, versus, say, some of the traditional ways we just deploy by hand in the past. So. And again, I think just like that learning is pretty key too. We actually just signed a lot of our folks up when they started diving into just general classes, things like Pluralsight, other things, like really just learn this stuff. Like, there's many languages out there from, like, say, like Bicep, Terraform, but give the team the time and space to learn some of these things, and you'll be surprised. Like a lot of engineers are excited when they see something new in this space. They all learn about, for us, we use Bicep, but like, Azure DevOps, Git was different because we're mostly Perforce, but like, again, once they dived in and got used to it, they definitely embraced it. So definitely something I would suggest for teams. And then this was an interesting one, actually, is that we found that like a lot of our applications we were running locally, especially just the stuff we authored ourselves, we kind of just like picked a version of something and just sat with it. So for example, .NET frameworks, like, oh yeah, cool, it works with .NET 5 or whatever, it's fine, just keep going. But then when you get into the cloud is actually very rigorous about like finding security flaws, and it will start pinging you and telling you that basically this is wrong, I'm going to shut down your application because something is bad with this version, which is a good thing because obviously it's public internet. You want to make sure this stuff is working. So making sure that you kind of stay on top of like keeping your apps up to date, using latest and greatest is generally a good thing. And again, I think when you get into the cloud, you'll figure out that that's something that's just kind of comes as part of that migration. But before you enter that kind of migration process, it's worth thinking about some of these things before you go. So, and then I think just like this infrastructure mindset and kind of responsibility shift, we actually had to sit down and really talk to our IT team and figure out like how do we work together going forwards here. Like again, in the past at the coalition, we would ask for something. I was like, hey, I need a VM to run this thing. They would be like, cool, here's a VM, go. And they would just give us admin and off we went. Like, I think you really need to sit down and go like, okay, what does it mean to give somebody access to something in Azure, like a subscription or something like that, like anything in the cloud? And who wants to handle what? Like, and if something goes wrong, like, are you going to allow someone to like just log straight into a prod environment, for example? Is that something you want to do? And these are the sort of things, again, which we didn't have that mindset before. But sitting down and actually just trying to figure out those roles and responsibilities. And actually one of our IT team actually shifted into like a DevOps kind of role and actually embraced a lot of the stuff in the cloud, which was great to see. And it's definitely something worth thinking about as you go through this. So, and this is the same thing of like, I don't know how other teams work, but for us, we have a really good relationship with our IT team. But I think it's actually building those strong bonds to begin with is vitally important. And I think we've got even closer because of this. Because they realize is like, hey, you could just go up and spin up 1,000 VMs if you wanted to, if you didn't have the right, or if you had the wrong access, if you will. So I think just kind of working together, understanding of like, it's obviously the dev team as well who makes some of these tools and workflows, but obviously IT are vitally important here as well. So again, work with folks together and you're going to have a good outcome here, I think. And I think this is something that I get asked a lot. And it is worth stating here a little bit of like, really you need to understand the costs versus the flexibility of what cloud versus on-prem can give you. The cloud can be expensive, for sure. There is a lot of things up there that, doing the wrong thing can start costing you a lot of money. But there is obviously, that cost-benefit analysis of like how flexible is the cloud, and is there different ways of doing it? Like there's things like an example in Azure, they're called like lambdas, I guess, in AWS, but in Azure, there's things like called Azure Functions, where you can just like, here's a payload, do some compute, send it off wherever you want, and they're far cheaper than like spinning up a VM that you keep hold of forever. So again, the technical choices you make will definitely be something to worth considering, like how you want to deploy these things. Do you have like scale sets to scale up and scale down? There's a lot of things you can do. And again, it's one of those things that can be scary on the books when you first look at it, of like how much you're spending every month, but it's definitely worth having that consideration. And it's, like I said, for us, we have on-prem build machines still, and I think we always will, because some of them, they're a little cheaper, that we can do a lot more things with them. But again, I would never get rid of the flexibility the cloud has given us. So, and with that, I have a little bit of time left for Q&A. So thanks, everybody.